TOEFL Integrated Writing Task. Writing based on reading and listening. For this task, you'll read a passage about an academic topic. A clock at the top right of your screen will tell you how much time you have to read. You should take notes on the passage while you read. The passage will then be removed, and you will listen to a lecture on the same topic. As you listen, you should also take notes. You will be able to see the reading passage again when it is time for you to write. You may use your notes to help you answer the question. You will then be asked to write a response that asks you about the relationship between the lecture to which you just listened and the reading passage. Using information from the reading passage and the lecture, answer the question as completely as possible. Please note that this question does not ask you for your personal opinion. Your response will be judged on the quality of your writing and on the completeness and accuracy of the content. Of course, with every theory, there are criticisms of it. With the nebular hypothesis, before any condensation of gas and dust could occur, the nebula would have diffused into outer space. According to Gerald P. Kuiper, a leading evolutionary astronomer, before gravitational attraction would become significant, the particles would have to be as big as the moon. In addition, this theory requires a complex system of roller-bearing eddies of gas and dust had to develop, which in turn gradually whirled out into suns and planets and moons. But this isn't a possibility, since such vortices would have to remain perfectly intact during essentially the entire period of planetary formation. On this point, Kuiper doubted that the vortices could last long enough to get the condensation building process of the planets underway. And the fission theory is not without its flaws either. While the moon was moving outward toward the Earth, gravity would have pulverized it into rings. Additionally, moon rocks are somewhat different in composition than the material on Earth. Immense outward explosions would hurl material straight out into space. They would not circle and then form carefully balanced orbits. If thrown off by the Earth, the moon should circle our world over the equator, but instead of this, it orbits our planet at a tilt of 18 to 28 degrees to the Earth's equator. Finally, the mathematical probabilities of the capture theory are extremely low. Given the great distances between the objects in space, the likelihood that objects would pass so close to one another is very little. Millions would have to pass near the sun or planets in order for one to pass closely enough. Another problem with this theory is that we see no planets flying by us today. If it were occurring earlier, it should be happening with great regularity now. But they're not. And even if they did pass near enough, gravity would crash into planets and suns, or they would merely fly past us. They would not pause and begin orbiting within our solar system. For example, how is it that the Apollo rocket, after being launched into space, begins orbiting around the moon? Because closely monitored computerized jets controlled by telemetry signals from space place it into a carefully predetermined orbit at a certain distance from the moon's surface. Nothing is left to chance, for scientists know that only failure will result. Therefore, based on my discussion, now you know the criticisms of the three theories regarding the origin of our solar system. Read the question below. Use the remaining time indicated to plan and write your response. Your response will be judged on the quality of your writing, as well as how well your response presents the points in the lecture and the relationship to the reading passage. Typically, an effective response consists of 150 to 225 words. How does the information in the lecture question the three theories mentioned in the reading passage? Pause the video to write your response now.